Our next speaker is Dr. David Brenner, the Director of Radiological Research, Accelerator Facility at the Center for Radiological Research at Columbia University. He is also the Principal Investigator at the Center for High Throughput Minimally Invasive Radiation Biodosimetry at Columbia University. So welcome to Dr. David Brenner.
Good to be here.
Excellent. Good day, Dr. Brenner, and thank you for taking the time to chat to us today. Dr. Brenner, as a general consumer, as you know, when people talk about UVC, the first thing we think of is, oh, you know, it's dangerous, and we've all been told we can't be underneath it, and it'll give you cancer on your skin, and it'll damage your eyes, etc., etc. Could you give our delegates some insight into the development of far UVC and what makes it so different to the UVC that we all know?
Sure. So UVC in general covers a range from less than 200 nanometers up to 280 nanometers. And conventional germicidal UVC, that I think what you were talking about, is generally comes at 254 nanometers from a mercury lamp. And there is no doubt that mercury lamp 254 nanometer light can penetrate into the skin and to the eyes. Far UVC is a lower wavelength range, somewhere 200 to 230 nanometers. And that has much less ability to penetrate the skin and the eyes. It gets very strongly absorbed by proteins, and of course all biological materials contain proteins. So it really can't penetrate significantly through the dead layer of the surface of the skin, the stratum corneum, or the tear layer at the surface of our eyes. So that's why it's different from conventional germicidal UVC at 254 nanometers.
That's quite amazing, because whenever you see a picture of the conventional UVC, the 254 nanometer UVC, one thing you do notice in those pictures that there are no humans around when those lights are on, correct?
That's correct. And you can't, in practice, directly expose people to significant doses of 254 nanometers.
Excellent. So what we're saying here is that, if I understand you correctly, is that the biggest downfall of 254 nanometer UVC, that people can't be in the area, far UVC has now overcome that hurdle.
Yes, that's exactly right. We hope that's true.
Excellent. Dr. Brenner, can you tell us a little bit more about, obviously, we know that you've been testing this product for quite a long time. Can you give us a bit more information about how you've tested this product, how long it's been tested for, a little bit more info on that?
Well, we first pointed out this potential for a differential between damage to microbes like bacteria and viruses and damage to humans, the skin and the eyes, about 8 years ago. And certainly we've been working on it ever since. But I will say that in the past 4 or 5 years, lots of other groups worldwide have been doing research both into safety and into the efficacy part of the story.
Fantastic.
Clearly, you have to understand both. You have to understand, is it really safe? And you have to understand, does it really work?
Absolutely. Dr. Brenner, the other question I want to ask you is, I've noticed that many of the manufacturers or distributors of far UVC products, they're putting filters on them. Could you explain a little bit more about why filters are being used on far UVC products?
Yeah, and we certainly think that if we're going to use this in occupied public settings, you do need to filter the light. So the background here is that the krypton chloride eczema lamps that Dr. Tarashenko invented, and what is pretty well universally used at the moment, although it's the most likely wavelength for emission is 222 nanometers, there is a background spectrum of light going up to 250, 260 and higher. And those, even though they're fairly small components to the overall spectrum, they can be significant in terms of damage to the skin. So we really need to filter out almost all the wavelengths above about 235 nanometers. So that's the importance of the filter, to get rid of the small amount of the higher wavelength UVC light.
Excellent. Thank you so much. Dr. Brenner, what some of the questions that we are asked is, how come far UVC can actually kill a virus or a bacteria, but it doesn't penetrate through your skin? Could you explain that a little bit more to our delegates?
Well, it's simply that viruses and bacteria are very small indeed. They're typically less than a micron in size. So the far UVC light can penetrate into a virus or into a bacterium. But for example, the stratum corneum on the surface of our skin is quite a few microns in thickness on average. So it can't penetrate, or it has very limited ability to penetrate through the stratum corneum. So it's simply a matter of size. The microbes are very small indeed.
Excellent. Thank you for the answer. And tell me something, Dr. David Brenner, does far UVC kill all viruses, all bacteria, etc.? Or does it only relate to certain viruses, certain bacteria? Or is it just, or can it kill everything, basically?
Well, in principle, it can kill everything. And the reason I say that is because the type of damage that UVC in general produces is random damage. It randomly damages locations within the genome and the protein. So it's not like a drug, which is targeting some specific location within the bacteria or the virus. I mean, in our own work, we started looking at MRSA, drug-resistant bacteria. It was very effective there. Then we went to influenza viruses, and then we went to coronaviruses. And it's been effective in all those scenarios, and pretty well equally effective. So our expectation is that it's pretty well equally effective against all coronaviruses and their variants, and it will be equally effective against future pandemic-related viruses that we might have in the future.
Dr. Brenner, you talking about, you mentioned AMRs, superbugs and antimicrobial resistant bugs, etc. You had on your TED talk, you gave an indication of how many people you thought would be affected by superbugs and AMRs by the year 2050, and your guesstimate was about 10 million people a year, and that was in 2017, I think it was. If we look at the trajectory now, I think the deaths this year are about 1,700,000. So this is clearly, obviously, the next big issue that we're going to be, that hopefully we don't, but it certainly looks like it's the next issue that we're going to be dealing with worldwide from a disease point of view. So my question to you really is, now that we're all getting back to the new normal, let's call it, and restrictions are being lifted around the world, in the UK and all over, do you still see a market for a product such as UVC and the UVC devices that people are promoting and pushing into the public and public spaces? Do you still see a market for this product?
Well, let's talk about viruses and bacteria separately. So starting with viruses, and yes, we hope we're moving towards the end game of the COVID, although we don't know that for sure. But speaking for myself, I don't want to live in a world where another pandemic can occur at any point. So the idea behind installing far UVC lights is that, I mean, had they been present at the start of COVID, the SARS-CoV-2 virus would certainly been there, but it wouldn't have had the global impact that it did have. And so when the next SARS-CoV-2 virus appears, we would like to have far UVC lights in place in all sorts of different locations where people mix, and so that the impact of the next big virus will be correspondingly a lot smaller. And then turning to bacteria, as you say, every prediction is that the issue of drug-resistant bacteria is going to become more and more relevant to us over the next few decades. And again, one of the great things about UVC light is it doesn't care whether the bacteria is drug resistant or drug sensitive, because it kills by an entirely different mechanism. So it's perfectly good at killing drug resistant bacteria. So being that that's a big issue that we're all going to face, that's the other area where far UVC, I think, is going to be able to have an impact.
Absolutely. So really it's about prevention is better than cure, or prevention is better than panic. Let's put it that way.
For
So
sure.
the sooner we start rolling out this technology, the safer we all are going to be around the world. Fantastic. Well, Dr. Brenner, thank you very much for your time. From all the delegates and from all of us that have put this seminar together, we really appreciate your time. Thank you so much. We look forward to engaging with you at the end of the talk with regard to some of the questions that might be answered that we might need you to answer. So thank you very much, and we'll chat to you in a couple of minutes.
You're welcome.